All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tried something a little bit different tonight with the ads. Tried running just a manual one up front just to sort of try and offset those a little bit and see how that works. And hopefully that disables pre-rolls for some folks as well. So we're trying that. Excuse me, we're trying that. And it looks like we've got about an hour before our first ad break. So maybe that'll be a good thing, maybe not. We'll see. Will Bites back. Thank you for the follow. Appreciate that. Welcome to the stream. Hot Tub John, welcome to the stream. Good to see you. Really quickly, before we get jumped into things here, I do want to take just a quick second and thank the supporters of the channel, starting with our partners who are the highest tier of subscription over on YouTube memberships and Patreon. They are Gabi Bashir and Gerboles Inc. I would also like to thank all the other supporters listed here on the screen. They are the other tiers of subscription on Patreon, YouTube memberships, as well as Twitch subs. So thank you all very much for your support. It is greatly appreciated. That being said, I do appreciate each and every one of you viewers, whether you are on the Twitch side or whether you are on the YouTube side. We do simulcast to both. I watch chats on both. Yeah, thank you very much for being here, following along with the series. Without you guys, none of this would exist, right? So, okay. So we're going to pick up tonight where we left off last night, where we started kind of getting a little bit into talking about scene saving. And we kind of went over some high-level concepts. I'll quickly review those, and then we'll jump back into getting some code written and hopefully having scenes saving properly by the end of the episode. So we'll see where we wind up on that one way or the other, right? Okay. Magetz, good to see you. Welcome to the stream. Hope you're doing well. All right. So, couple things that we were talking about last night is we now have this concept of a read-only mode when we're actually reading in the scene itself. And so what that basically means is we have two different types of scene loading. There's a read-only mode, which is what you would typically use in your end application. That's when you're actually playing the game and whatnot. And then you have the sort of writable mode where you can actually make changes to the scene and save it and have that actually export to a file. And that is the mode that you would want to use from the perspective of an editor. So in terms of what the testbed is going to use, we are going to use that that sort of write mode. We can flip back and forth between read-only and whatnot and the testbed as needed to test those different things. But the biggest difference between those two is A, obviously you can't save the scene if you're loading it in read-only mode. But B, when you load a scene not in read-only mode, there is also scene metadata that is kept with each one of the nodes. And the idea there is that we need to keep data that is provided along with the scene's configuration in order to be able to successfully write that scene back out to file later on. So, for example, if we have mesh attachments, we need to know what those resource names are, etc. Anything essentially that we can't extract from the actual thing itself, such as an attachment or a node. Name would be another example of that. The runtime doesn't know or care about those things once the thing is loaded, right? So any of that kind of information we want to go ahead and hold on to, so that way when we go ahead and serialize that back out to disk, we have the information we need to do that. Let's see, first time chats. Will Bites, yep. Really loving the series, learning so much. It's been a really long time since I did an EC. Well, awesome, welcome. Glad to have you here. Glad it's useful. That kind of feedback definitely helps, so I appreciate that. All right, so where we kind of left off last night was we had this sort of, we have this concept of scene metadata that we were setting up. So the scene metadata, or scene node metadata, I should say, for right now only has an ID and a name. And we probably will be adding to this. But for right now, each node will basically have a name that's saved to it, right? And so we have an array of those, just a flat array. And then we also have a count of metadata. And so if we think back to the way that we set up our new scenes, the concept of a node is only really just a concept. The actual node itself doesn't really exist in the scene. A node is comprised of a hierarchy, node, right, which is in our hierarchy graph, which determines parent and child relationships. And then that can potentially also include a X form, so our transformation within the world. So there is nothing known as a node, right? We work exclusively through these handles. So we create, whenever we're initializing a node, we create a node handle, which is really just a handle into the hierarchy graph. And then we also create a X-form handle if the node is configured to have an X-form. Otherwise, we just use an invalid handle for that, right? And so through the combination of these two handles, we have a node. And so as far as the editor or anything else goes, it doesn't know anything about how nodes work internally, and it doesn't have to. We can simply look up into this array of metadata for scene nodes. So the idea here is that we are going to index into this array using the node handles handle index. And so anytime we go ahead and initialize a node after we've obtained the handle, we're going to make sure that this should actually be if not is read only. And so anytime that we actually stand up a node and we have the node handle, we are also going to ensure that we have enough space in this array to hold it. And then we're going to go ahead and set up that node individually. So a slot in this metadata array is basically marked as unused when we have invalid ID there. And so that goes hand in hand with the hierarchy system, where we can have unoccupied space in the array when we actually unload a node, for example. So we're basically going to use the same index for each. So the idea is that the size of this array is always going to be the highest ID plus 1, right? And that's how we're going to index into this. And then we'll keep a track of this count here. And so we'll have a function that we call to ensure that the scene node metadata is properly allocated. And then we can go ahead and set the data as we've done here, right? So we kind of got about halfway into that. And now we're going to be completing that portion. And then once we have all the metadata that we need, we'll then be able to reach into this array and be able to serialize that data back out to KSIN, right? We also do have a little bit of code to move around. So we do have our deserializer right now exists in the scene loader, which is not really where it belongs. That really should exist probably either in the scene file, or maybe we'll create a scene serializer file and put all that code in there. But we'll worry about that once we get it working, right? Let's see, Lou the Coder, let's go. Yes, awesome. Welcome to the stream. Let us go indeed. Okay, so the first thing that we need is a way to ensure that this this array contains what we need. So I'm actually going to go, I think I'm going to forward declare this. And we're going to use, let's see, this is dead code. I think we can get rid of that. We'll say static void scene node metadata ensure allocated. We're going to pass to that the scene. And I think that's actually all we're going to need. We're going to need to know the current ID that we're trying to ensure we have enough space for. So let's do U32. U32, I think it can be a U64 actually. Handle index. Right. So we'll take that and we'll go down to the bottom of the file. And looks like we've got some dead code here we actually need to resolve. This is our save, so let's go ahead and put it right below the save. We'll put it here. All right, so we've got that. And first and foremost, we obviously have to say if s exists, right? And handle index is not equal to, and whoops, not equal to invalid ID U64, right? So, oops, I typed C, I meant S, right? So if we have a scene and the handle that we pass is not, or the handle index we pass is not invalid, then the first thing we'll do is we'll say if S node metadata count is less than handle index, right? And this should actually be +1, right? So if that is, if that's too small, right, then we're going to need to reallocate. So what we'll do is we will say, let's do scene node metadata array. I guess we'll say new array equals kallocate size of. We'll do scene node metadata times, and we'll do handle index, right? And then memory tag scene, because that's kind of where that lives, right? So we'll do that, and then we'll say if s node metadata, right? So if that exists, then we'll go ahead and copy the old data into the new array before we nuke it, right? So we'll say k copy memory. The destination is going to be new array. The source is going to be s node metadata, and the size is going to be s node metadata count, right? And so we'll copy over that so that we don't lose the data. And then let's see, we can go ahead and k free, and the block we're going to free is going to be s node metadata. The size of that was size of scene node metadata times s metadata count, and we're going to free that under the same tag, which is going to be the memory tag scene, right? Dottie, thank you for the follow. Appreciate that. Gino the Gnome, thank you for the follow as well. Appreciate that. Welcome. Apotham, good to see you. Welcome, welcome. All right. So that is going to handle that for us. And then what we'll do here is, actually after this, we will say s node metadata, equals new array, right? And that will ensure that we have enough space allocated to actually include this guy. The other thing that we're going to have to do is we should probably invalidate those new entries, right, before we actually update this. So before I forget, though, let me set s node metadata count. You know what? Let's actually create a new count. And actually, I put the +1 in the wrong spot. Right, so let's do U64 new count equals handle index +1. And we'll do new count, right? And so we'll set this to new count. And we'll need to invalidate. Actually, we need to do that. Let me see. We actually need to do that outside of this because that needs to be done either way. So for u64 I equals 0, I is less than, I guess this can be a u32, right? So I is less than s node metadata count. No, that's not right. I should start off as equaling that, right? So we need to go from that forward through the array. Xantham, thank you for the follow. Appreciate that over on the YouTube side. Welcome. Shouldn't size be metadata count times size of node metadata? Yes, and actually this is wrong here. This should be new count. Yes, that would have been wrong for sure. So we're going to do s. Rather, let me do the size of first. Scene node metadata times that. Good call. I almost missed that. All right, so we're going to start off at the old metadata count. We're going to say as long as I is less than new count, plus I, and then we'll say s node metadata sub I ID equals invalid ID u64. Or is that a 32-bit? That is a 32-bit. Okay. Okay, so invalidate all new entries. Right? And then we'll essentially update the count and we should be good to go. What did I... There we go. Okay. Let me just review this in my head really quickly to make sure I didn't miss anything else. I don't think I did. I don't know why my auto formatter is doing that, but okay. Fine. Okay. That looks correct to me. Oh, this is going to be wrong. This has to go up here. There we go. So we need to set the new array before we do this. Otherwise, we're going to segfault and then update the count, and we should be good to go. And I'm thinking since this is really only ever going to be called in like editor mode, if we fail to pass either the scene or the handle index not being invalid, let's bleat about it. We'll say kwarn, whoops, and we'll say scene node metadata ensure, oops, there it is, requires a valid pointer to a scene and a valid handle index. Right? We're not really going to do anything about it. We're just going to warn about it. Just so if we see that in the logs, we know to check out, you know, some sort of weird binaries that's going on there, right? Okay, so we have that. So I think at this point, we can go ahead and let's see. Right here. So if we are not read-only, then that means we need to do this. So we're going to say ensure allocated. We'll pass through S, and the handle index is going to be node handle index, right? So we'll ensure we have enough space for that. And then we'll go ahead and do this. So we have this for attachments as well. Let's move this down here for now. Handle resize manually to ensure space. We did that. And we did that. Okay. So that's going to handle the node-specific metadata, right? And we only do that in not read-only mode, right? Okay. So the other thing is for attachments, which is here. So attachments are going to be a little bit different, right? Because the data that we save off varies by attachment. So I'm thinking, since we actually do have a list of attachments, and we have different arrays for all of those attachments, we could probably just like slam this data straight into the attachment itself. And we can basically just allocate that if we need it, and don't allocate it if we don't. I think that's probably going to be the best way to handle this. That way it allows us to do it by type. We can, yes, it's going to actually cause another allocation to happen, but that's only going to happen in the context of an editor, right? It's not going to happen in the runtime, so I don't see any downside to doing this from a performance perspective. I think that makes sense. So ones we're going to need is like the attachment of the static mesh type is going to need that. Specifically, it's going to need a copy of this resource name, right? Spiro with the 5 community subs. Thank you, sir. I really appreciate that. That really means a lot. Thank you. Thank you so much. How are you doing? What are you up to today? Scallywag Software. Good to see you. Hello. Hydrate for 100. Appreciate that, hot tub, John. All right. Family day at the mall. Don't even have the sound on, hang out with kids, so I didn't stream, had to drop a 5. I appreciate that, man. Thank you. And you just said you didn't have the sound on, so I'll answer you in text just to be sure. I'll DM you later for sure. But if you can't hear me, I really appreciate it. Okay, so if we peek definition on this, oh, we already actually do store the resource name. We might not actually need metadata for some of this stuff anyway, because we actually keep it in the attachment itself. But I think this is more like a config type of thing. Let me see. So we have mesh attachments. So resource handle. So I think, you know what's a little confusing actually, now that I'm looking at this? These are really configuration items, right? These are not what's actually, these are not the actual node attachment themselves. These are configuration items. So I was like, wait a minute, we don't actually store this information off. So I suppose like one thing we could do is just use that structure. I don't really like that though, because the metadata may include different sets of data than what's just in the configuration. Because essentially what we do is, again, like similar to the nodes, like the node attachment itself doesn't actually exist as a thing, right? The only thing that really exists as far as that goes, is the actual resource itself, like in this case, a mesh, an array of meshes, and we have a handle into that array, right? So we don't actually have a mesh that we can sort of hook this onto. Carl, thank you for the YouTube sub. I appreciate that. Welcome. So we might want to go a similar route for these, right? Maybe we just have an array that sits alongside of these things, right? Which would make it really easy to access the metadata, right? Because you could just loop through those things. They'll all be data local, right? We could also use the handle that we create, the resource handle, as the index for that, is what I'm thinking. I'm trying to think if there's any downside to doing it that way. I don't think so. I don't think so, right? Here's where we create the handle. So I think we can literally just create metadata alongside of it, and it should be fine. So I think that is how I'm going to do it. So the only ones that are actually going to need this, at least for right now, we have to do it for meshes because we have a resource name. We have to do it for terrains because we have a resource name. We have to do it for skyboxes because we have a resource name. The lights themselves don't really have anything that actually loads, so we don't need anything for that. We can actually pull the light data, or the data from the light itself, to actually get what we need there. So I think from that perspective, we should be fine. So I guess what we'll need to do, let me move this over so I'm not coding behind my head so that you guys can see what I'm doing. Let's do, so we already have our scene node metadata here. Let's do type def struct, let's do scene mesh attachment. Wait. Maybe we do scene static mesh metadata. Right? And in this case, it contains a resource name. Scene static mesh data. Or metadata, rather. Okay. So for scenes, or for meshes, rather, we do static mesh metadata. Mesh metadata. We'll say an array of mesh metadata. Right, so we'll create that there. And then over here, we will do s mesh metadata sub I resource name. And here we're actually going to take a copy of the resource name. So the resource name should be here. So we are actually taking a copy here, but I'm going to take another copy anyways because this config is eventually going to be killed off. So we'll do string duplicate, and we'll do take this from typed attachment config resource name. All right, so we'll hold on to that and we'll say if we'll do this if not is read-only. Right, so we'll only do that in editor mode. And then we'll do the same thing here. So if not is read-only. And we'll say darray. Actually, can we do... No, we'll have to create a struct and push it into there. So we'll do scene static mesh metadata. Mesh metadata. Right, and we'll do mesh metadata resource name equals string duplicate. And in this case, we'll do, again, typed attachment config resource name. And then darray push. And we want to go into s mesh metadata. And we want to push mesh metadata. Let's actually do... Let's actually call this new mesh metadata. Okay, sure. All right. So for edit mode, retain metadata. Right? And that's basically the pattern that we're going to follow. Across the board. Okay. We should probably... We're also going to need to make sure that these darrays are created when we initialize the scene, so that we don't run into seg faults there. So that's going to be a thing too. But I think we actually have everything we need. So let's take these two lines, and we have terrains, terrain attachment indices. Let's put that here, and we'll call this terrain metadata. We're going to create essentially a copy of this, and we'll do scene terrain mesh metadata, scene terrain. Oops, actually it should be just be scene terrain metadata, no mesh. Scene terrain metadata. And I think, did this one need both a name and a resource name? I'm trying to remember. Thank you for the follow over on the YouTube side. Birkin, I think it was. Yeah. Appreciate that. Welcome. The preview is like really small on the YouTube side for some reason. But I appreciate the follow over there. Diamond, good evening. Good to see you. Welcome to the stream. Hope you're doing well. All right. So I believe this just needed... Yes, it needed name and resource name. Okay, so let's do that. Right. So this is going to be scene, this one, terrain, metadata. And while we're at it, let's just make this kind of consistent and put the attachments here with it. So we're going to say, let's take this one, the terrain attachments, and let's put it, let's see here. And we'll say array of scene attachments, attachments for terrains. Right? So that's terrain attachments, terrain metadata. So essentially, we're going to wind up taking a copy of this here for terrains. And we're going to say terrain metadata, resource name. And let's see, we have typed attachment, resource name. And then name we'll take a copy of too. That way we have that to be able to write back out. And then we'll take a copy of the push version of that for here. And again, this is going to be terrain metadata. New terrain metadata. So we're going to take resource name, and that's just going to be typed attachment. Resource name and name. Right? We're going to push this into terrain metadata. All right? So we've got that for terrains now. And now we need to do skyboxes. So let's first take this guy and put him down here. Right, so this is array of scene attachments for skyboxes. Right, and remember we can have multiples of these because we can like fade between them and stuff. And then we need to create a type for that, which I think this one went with cube map name. So let's peek definition on this one. And we'll do type def struct scene skybox metadata. And this is going to have a constant character array called cube map name. Right, and this is going to be scene skybox metadata. Okay, and we want that here. So we have scene skybox metadata array skybox metadata. And this is going to be array of skybox metadata. Right? And so again, we're going to follow the same concept. So I'm going to take this copy here, go down to skybox, put this in here. So skybox metadata. This is going to be cube map name, and then cube map name here. And we don't need a name, right? So we just have that, and then we also need a copy of this guy, right? And we'll put that here in the push logic. So this is going to be scene skybox metadata. This is going to be cube map name, typed attachment cube map name. Don't need that one. New skybox metadata. And we're going to push that to skybox metadata. Now, I do know that we have a lot of repeated code here, so we are going to make an effort to get rid of that at some point, but For the time being, we're just interested in getting things to work, and then we'll refactor later, right? Okay. So I think we've covered all the types that we need. So we create the one second. Okay. So at this point, we should have everything that we need. We need to handle the creation of these new arrays on... Do we want scene initialize? Or do we want... No, I'm thinking we want scene create. Yes, that's what we want. Okay, so... let's see. We do have the flags in here, so let's go ahead and say. In fact, I'm just going to cheat and grab this and S flags. So this is going to be out scene flags. We can actually move this down a little bit. We'll move it to here. All right, so we have read only. So we're going to say if not is read only. Okay, so if not read-only, that's when we need to create these arrays. So we'll do out scene, and we only have to actually create some for mesh metadata, right? So that's going to be darray and it's going to be a type of scene static mesh metadata. So we need 2 more copies of this. So we need terrain metadata. And this is going to be terrain metadata. And we're going to have skybox metadata. And that should do it. Right? Otherwise, those will be zeroed out and they won't be available. Okay. So when we go to save, we're going to need to access those as we traverse through the scene hierarchy. So let me think about how I want to actually handle that. Do we have I don't think we've actually traversed the scene hierarchy yet. Right? So if we look at query, yeah, because we only go by types of attachments, right? So we look for meshes, we look for terrains, we look for, I think the skybox we pull directly, which we do need to fix that too. So save. Scene is basically where we're going to have to do this, right? So let's get rid of this error. And this is going to be like once we actually have everything serialized, this is how we're going to write it out to the file. I'm not going to worry about that yet, but we'll keep that in there just so that we have it. Hierarchy graph. Do we have we do have the view that we should be able to use, right? We should have access to that. And actually, I think that's sort of on the graph itself. So if we do S hierarchy view, there it is right there. Okay. So let's just actually save that. Hierarchy graph view. We're just going to save a convenience pointer to that. Right, oops. So just take a pointer to that. And we'll do view nodes, right? So we have root indices. I'm trying to remember how we actually so we have node handle. Right, that's the flat list of nodes. Okay, so we basically have to iterate through this using indices. And I'm actually wondering if there's if we should actually create a view that's a little bit easier to use than this. I suppose I could implement it this way for now, just to sort of act as a test for the way that this works internally. And then maybe we make an easier to use view where we don't actually have to look up the nodes out of the array every single time, right? So we're going to have to do this. We're going to have to do this recursively. Similar to how we did the deserialization, we're going to have to do the serialization recursively. So we're basically going to want to wind up following the same model. We're going to loop through each of the root nodes. And then for each of the root nodes, we will loop through each of the attachments, serialize those. Then we'll loop through each of the children of those nodes, rinse and repeat. Okay. So let's see. Let me check one more thing. Okay. So parent index we don't really care about in this case because we're only going to work top down in the tree. I'm thinking we might want to make a function that'll return like a pointer to the node without having to look it up all the time. But for now, is this a... I think our root indices is a D array. Yeah, it's a D array of indices into the nodes array. Okay. So we can do U32 root count equals D array length root indices, right? And I suppose we should probably be safe and say, do we have view root indices? Because we might not. All right. So we'll loop through each one of those. So we'll do for U32. I equals, actually, you know what? Let's do, yeah, that's fine. I equals 0. I is less than root count plus I. And then, whoops. Where did that just put me? There we go. All right, so within this, we can do the U32, I guess it's going to be, yeah, U32 index is going to be equal to view root indices sub I. So we get the index first, and then we go ahead and we get the view nodes. So hierarchy graph view node. Graph view node. We'll grab a pointer to that guy. So this will be the address of nodes sub index, right? So now we have the node, and we can loop through serialize attachments, and then recurse children, right? To-do. All right. Singy, hello. How's it going? Good to see you. Let's see. You notice a nice hack with C. Let's say you have a string structure that stores the string as length, uint, and pointer. You can pass the structure to printf like that, requiring that you have %*.s as a format insert in the format string. We'll consume the string length and then a string pointer nicely, sub string printing, quite simple. Interesting. So, I'm just trying to think about how. Oh, dang it. It thinks you posted a link. You know what, Magats? You've been here long enough. I'm going to VIP you so it stops doing that to you. Okay. Let me try that again. There we go. It banned you for 30 seconds. I'm probably going to have to change that a little bit, right? I had problems with like people spamming links for a bit, so it's a little overzealous now, I think. I'm going to have to balance it out somehow. From Lake, good to see you. What are we making today? So today we are working on serializing the scene. So right now what we're doing is we're traversing the hierarchy graph. And then we're going to write our serialization routines to take the node and attachment information, serialize those to case-in objects, and then we'll take all of that case-in tree that we create, and we'll pass it off to the parser to actually write that down to a string, at which point we can actually write that to a file. So that's kind of what we're working on. Yeah, Magets, unfortunately, it also killed your previous messages. Would you mind messaging me that on Discord? Like, just ping me? Just so I don't lose it, because I want to investigate that thing that you were talking about the string formatting, because that sounds kind of awesome. I hadn't seen that one before, but it sounds like a nice hack. Really? It timed you out again, even though you're a VIP? What is... All right, you know what? I need to look at that setting. because that is a bit much. Let's see. Give me 1 second to sort this out. Interesting. I wish there was a way, like, there's no way to actually... I guess maybe regulars? Let's try that. Yeah, you got timed up. Magetz, can you type something that looks like a link in 30 seconds when your timeout is over? I just want to see if it works. It's probably already actually over. Is there a way to ban everyone in the channel, even if one posts a link? I mean, I could write my own. Wow, it's still actually all right. You know what? I'm gonna turn that stupid thing off because apparently it is not smart enough to understand what it needs to block versus what it should not be blocking. So I'm gonna turn that off. And I guess if it gets out of control, I will return it back on. Give me 1 second to just switch back to... Okay. We have ads here in just a second anyways, but the automod is not needed. We're decent people. Yeah, I agree. I did have issues with people spamming links like early on, and so I've just kind of had it enabled for a while, but I just turned that off, so... it's actually not even Twitch's automod doing it, it's Streamlabs, which I don't think I need that on anymore, because I think Twitch's automod will catch it. So yeah, I guess, Magetz, if you would be willing to try that one more time when your timeout expires. We're about to have ads anyways. There it goes. Perfect. All right. I wasn't sure what you were trying to link, but yeah, it should work now. The way that it should work is Twitch should allow, like, if you're a VIP, you should be able to spam links. Otherwise, you shouldn't be able to. But there was an additional thing that I had on in Streamlabs that was also doing that. So I've turned that off now. Bots spam on low viewer channels usually. Yeah, they do, unfortunately. Getting ready to spam links to KNR. Yeah. I prefer that you don't. I mean, I could time you out manually, right? Okay. You've been saving up all your Rickrolls for this moment. Exactly. Okay. Huh. That's pretty sweet. Okay. I've actually been thinking about implementing something like this anyways. So what Magetz is talking about is essentially, like, you've got a string structure, right? Which is something I want to put in place at some point anyways, where if you have the length first and then the actual internal string next, you can actually printf that by using this format, which is actually pretty friggin' sweet. I like that a lot. What I've done in the past is I've put the string as first in the struct, and then you could just use the %s if it's first in the struct. But yeah, this is kind of a cool little hack as well. You don't actually know if the printf prefers the string as length. The string length is int or uint. That's a good question. I feel like I feel like I think it might use ints by default, if I'm not mistaken. Yeah, I'm not 100% sure. Anyway. We were looking at that during the ad break anyways. So the ad break is basically over now, which means we can get back to it. But thanks for that. I will definitely look into that a little bit further. Okay. Now the string T is more of a string view from C++. Yeah, fair enough. That is something we're going to do, is implement like a proper string library. Sometime soon, right? Before we get writing high-level code. I may do that mostly off-stream, though. Just because I don't feel like that's something I need to necessarily stream the whole thing. Could probably just review it after the fact. All right. So... how do we want to handle this, right? So we have the node itself. So we could probably just go here and say static. Let's do void for now. I'm not sure that I'm going to need to check for like failures and stuff. Yeah, you know what? I am going to check for failures. So let's do scene serialize node. And this is going to take the scene itself. It's going to take the... actually, do we even need the scene? Yeah, we need the scene. I'm going to pass the view, too. Whoops, view. I know I could get it from the scene, but this way I just have a convenience pointer to it. I'm going to mark these both as const, though. Because we shouldn't be modifying those things. So we'll do that, and then const hierarchy graph view node. Right? And so if not seen or not view or not node, return false. Right? Otherwise, return true. And we may have other error conditions in there. So within this, we'll have, we can actually move this here. Right? And we'll do, oh, you know what? We actually need to, we're going to need to create the case tree and pass that through as well. Come to think of it. So before we can even get to this point, right? Because we're going to need that at every step of the way as well. So case and tree. And we're going to call this I guess we'll just call it tree. Heck with it. Right, tree root. So we need to set up the root. So the type is going to be case and object type object tree root properties equals darray creates case and property. Okay. So we need to create the root element of the tree that everything goes into, right? So the root of the tree. Let's see. Kokala over on the YouTube side. Hi, I'm glad I could finally catch a stream. I was wondering if you have an online game and you want to save data, what would you do? Wait, would you do it over HTTP or some other protocol? Highly, highly specific to the type of game, right? And how much it has to update. Something that only updates once per user interaction, like clicking a button or something like that, you could do that easily over HTTP, or better would be HTTPS, right? But anything else, you'd probably want to establish like a socket connection and go over either TCP or UDP, depending on what data you're actually sending, or a combination of those two. Now you're mentioning HTTP, so I'm thinking maybe you're talking about like a browser-based game, in which case you'd probably want to use WebSockets. So it really depends on what you're doing. That's kind of a nebulous question, unfortunately. Okay, so we have the tree. So there's a couple things that we need to extract. Let's actually open up the scene KSN. So we need to create a properties property and a nodes property. And then we need to actually add like this in there, right? So before we can even begin processing this hierarchy, we have these top level properties we actually need to handle. So we'll do properties, right? So we'll say case and properties. Right, and this is going to be properties type equals casein property type, and this is going to be object. Right, so properties, and we want name is going to be properties. Because of the way that this tree gets torn down and destroyed, we're actually going to want to do a string duplicate on that. We want to actually use heap allocated memory so that we can free it later on. And then properties value. Object. Properties equals darray create, and this is again going to be casein property, right? And this should actually be ray, by the way. Wait, no, object was correct. What am I doing? All right, so now we need to add the actual properties to the properties object, if that makes sense, right? So we're basically going to fill this guy out. So we're then going to say, let's do the name first, right? So casein property, name prop, right? And name prop type is going to be casein property type string, right? And then name prop value. Well, actually, name first is going to be string duplicate, and that's going to be name, right? And then name property value s is going to be string duplicate, and then we're going to want s name, right? So we're going to extract that from the scene itself. Then we do darray push. The array that we're going to push into is properties, let's see, properties value dot o dot properties. Did I do that right? I think I did. Okay. So the value that we're going to push in there is going to be name prop. Right? And then we'll basically do the same thing for description. Right, so, oops. So we'll do description prop. Right. And then the name of that is going to be description. And we want the scene description written out, right? And then we're going to do description prop. So we push those both to the properties of properties, which is a little bit nebulous, I guess, right? But when you look at it in this context, it does kind of make sense. And then we need to de-array push. The array this time is going to be tree root properties. And the value that we're going to push is going to be properties, right? So that pushes that into that root object. Next thing we're going to handle is nodes. And this is basically what we're going to pass around as we're traversing the hierarchy tree. So we're going to do casein property. And we'll do nodes. We'll do nodes prop, I guess, equals 0 nodes prop type equals casein property type array. Right? Nodes prop name equals string duplicates nodes, and nodes property value object properties equals darray creates casein property. Right? Now I'm thinking we might want to simplify this process. As I'm using this API, I'm kind of thinking about some of the things that we might want to change and improve, right? So having to do this all the way down kind of sucks a little bit, right? We should be able to just say, hey, maybe create property with this name of this type, etc. Just pass those as arguments instead of doing it this way. But for right now, this will work. So, essentially what we're going to do there is, so this nodes will get us up to this point. And so at this point, each node is going to be represented by this. And so that's actually where we start popping into this, creating a new node property, or new node object, I should say, which is an unnamed property, and pushing that to our array. I hope that makes sense so far. Okay. So we have the node. So the next thing we need to do is actually set up a casein property. And we're going to call this node. Right? And nodes type. Oh, wait a minute. I don't think I can say node, can I? I think we use that somewhere else. Yeah, we use that right here. Let's call this node let's call this view node, right? And let's call this one node, which means we should probably also rename this one to view node, right? View node. And then we have node. So we'll say node type is always going to be object. So KSON property type object. Node name. In this case, since we're pushing to an array, it's always going to have no name. So no name for array elements. Actually, just no name for array elements, right? We don't need a name there. And now we can say node value dot o dot properties equals darray creates, and this is going to be KSON property type of array. And then at this point, we would pass this along with everything else here. So we'll say KSON property pointer node. And so that allows us to call here. We'll do scene serialize node, pass through scene, pass through view. The view node is just going to be view node. And then we'll pass through the address of node, right? And if for some reason this fails at anywhere along the scene or anywhere along the way, we will bleat about it, right? So failed to serialize node, see logs for details, right? So this is sort of reporting just a high level failure. And at this point, if we fail to serialize something, like the whole thing is going to fail, right? We don't want to write that out. Okay, so we pass that through, and then from here we do a let me think about this for a second. So a darray push nodes property dot value dot o dot properties, and we push through node, right? So we add the node to the array, and then once we've actually gone through the entire array all the way down, we do darray push tree root nodes. Wait a minute. Tree root properties, rather. Nodes. Right? So we push the nodes array object into the root properties. Right? And at that point, we will have everything that we need. It's nodes property, rather. Right? So that way, at that point, once we get here, the tree will be fully constructed, and then we can move off to the next step of this, right? Which is essentially passing that off to the parser to convert that to a string. And then from there, we can write that from to file. So the only thing that we need to do is we actually need to handle the node serialization now by taking all of the properties per node, serializing those, and then serializing the attachments and the children next. So I think so we create the node here, we serialize it, and then we push the node here. So this is more or less the way we're going to handle children too recursively. Okay, so up here, we'll do serialize top level node metadata, etc. Right, which we only really have one thing in node metadata. So we have view node node handle, and we want to use the handle index into s node metadata. That's how we're going to index that array. So I guess we'll just do node metadata, scene node metadata, node meta equals, and we'll take the address of this, right? So that we don't have to do that more than once. And then what we can do is we'll take the, we'll do a case and property. Case and property, let me think. Yes, okay. So we'll take a case and property, and we're going to say name prop. We're going to name prop type equals. In this case, it's going to be case and property type string. Name prop name equals string duplicates name, right? Because we also have a node name. And then the name property value is going to be string duplicates node meta name. And then we take that property and we do a darray push, and we want the node that's passed in value o.properties, right? So we want to pass to that name prop. Okay. So we do the name, and that's how we get the name. Let's see. Oh, this should be value.s. Right? So that's how we get the name. And if we add other properties to it, other metadata properties, that's how we get those as well. We may eventually have like user data that we want to store here, or like tags or things like that. So this will probably wind up being expanded for sure. So the attachments, I spelled attachments wrong here. Attachments are going to be the next thing. So we want to loop through a list of those and serialize those attachments and add them to a new property, right? So we actually need to create that property first. So let's do that here. So we'll do attachments, right? The attachments to the property, not the actual attachments themselves, right? The array. We'll do case and property, attachments property, attachments, property, and the type is going to be an array. So case and property type array, attachments property name is going to be string duplicates attachments, right? And attachments property value o properties. And that is going to be darray create thinking here to make sure I did that right. Yes. Okay. So darray creates, and then this is going to be casein property. We should probably also set the attachment property value o type to casein object type array. Right, we need to make sure that that's marked as an array. I'm pretty sure we forgot to actually do that in a couple spots here. Yeah, so we need to do properties value o type equals casein object type array. So we've done that there. And there's one more spot we missed it down here. Okay. And then let's see, this is this one actually is, oops, node value o type equals object type object. Okay. Can't forget to tag that, because when we go to serialize it, it's going to screw up if we don't have that. Okay, which is one reason I'm saying like we might want to actually like create functions to simplify this a little bit. But for now, let's just get it working. Okay. So we have this. We're also going to do, we're going to push this afterwards. So this is going to be node value o properties, and we're going to push to that attachments property, right? And then essentially the children are actually going to wind up being kind of the same thing, right? Because the children, if we look down here, is also an array of objects, just like the attachments, right? So I'm actually just going to take a copy of this and put it here. And we're going to say serialize children. And we're going to call this children property. Right? And this is going to be children. It's going to be a type of array. Decreate that. Darray create that, rather. And then children property. So we push that as well. And then last but not least, we also have the X form, which is down here at the bottom. We can put this up here at the top level thing after top level ads, because we have ads. So for those of you who are new to the stream, I do pause the stream whenever ads come up on the Twitch side. They're served to us once every 30 minutes for 90 seconds. So I do like to just kind of put the stream on hold while those are running so that nobody misses any content. And also, I usually suggest people hydrate during that, right? And so, let's see. Freezer Burn, I do see your comment. I will answer that in just a minute. So we've got about 20 seconds left on ads, a little bit more than 20 seconds, and then we will continue. All right, and cool. Ads are dead, and we're back. All right, so Freezer Burn 26, first time chatter, welcome. You're asking, hello, I've been watching your videos. Welcome. I'm like 150 episodes back. Just curious, do you ever update your Clang version on Windows? I accidentally updated it on Winget, and nothing builds after doing that. I was trying to decide if I should uninstall everything or see if you update Clang version later. So I am actually currently running Clang 15. I haven't updated in a while, but I have updated beyond the initial version of Clang that was there. I don't recall when I did that, but I do remember that there were some issues because I think I started off on like 12 or something like that. So we did update. I'm about to update again. And so it's hard for me to say what it would have broken that far back. But generally speaking, I think it was just like syntactic stuff, right? Minor syntax issues. I don't think there was anything majorly broken. I think it was just a few syntax things that had to be fixed. I can't recall though. It's complaining about some new C version things, it seems like. I wonder if it's compiling in like a newer version of C. I don't think I'm specifying. I probably should specify. Let me see something real quick. So we might want to do, you might want to do something like adding, std C11, or maybe try C17 and see if that works. Maybe it's using like a newer version of C that like breaks stuff. I'm not 100% sure. But try adding that, std C11 and see if that works. If it's defaulting to C23 mode, I think there are breaking changes. Yeah, that's what I'm wondering. I should probably look into that, actually. I'm going to write that down. Right. I don't know what those breaking changes are. I'm wondering if try specifying the C version. And I may have to like go back and patch the videos somehow to handle that. Although there's not really a way I can easily do that retroactively either. But I would say try that. And then I'll look into it and see what I can find. And then maybe I'll put something on the Discord server and or on the website and or on the videos themselves. What video did you actually run into breaking changes on? Are you like 30 videos in or something like that? You can just uninstall Clang and reinstall 12 if that doesn't change anything. Okay, yeah, I think I started off on Clang 12. It's been quite a while. You're on like 41 after the roadmap. Okay. And I think I updated sometime soon after that, I want to say, but it wasn't to like the newest version of Clang. I'm not even running the newest version of Clang on this, which I probably should be. So, yeah, I'll investigate that and see what all is breaking. Because that kind of sucks. We don't want to be in a situation where newer versions of it are breaking the game, because that's the game engine rather. So I will look into that. But yeah, for now I would just roll it back. All right. Xform is what I was going to do. Okay, so we can take this, and actually the Xform is going to be very similar to this. Except it's going to be conditional. So when we are talking about Xforms, remember that nodes aren't required to have Xforms, right? So this node has an Xform. This child node has an Xform, for example, right? This one down here has an Xform. But if we go up to here to this environment node, it does not have an Xform. Because Xforms don't really make sense for things like a skybox and a directional light, right? Like, we don't really need an Xform for that. Thank you, by the way, for the follows over on the Twitch side. Appreciate that. So since Xforms are optional, this too needs to be optional. So what we basically need to do is take a look at the node itself to see if it has a valid handle, and then do Xform. So actually, let's just do that here. So we'll do node. Wait. I did call this node, right? Didn't I? View node is what I need. So I need to look at view node. So if the Xform handle on that is not invalid, so we'll say k handle is invalid, right? And we'll say if not invalid, then we'll do this, right? And so let's just rename this Xform property, right? And that'll end up getting pushed into there. Now, the name is going to be Xform, and its value is obviously not going to be string duplicate anything. We're going to take the Xform itself and basically toString it. So Xform, let's see. We have from position, rotation, scale. Do we have a toString? Or do we have a string? I thought we had. I could have swore that we had string to Xform config. But we don't actually have an Xform to string, do we? Okay. Not a big deal. We'll have to write that real quick. So Xform, Xform system. Let's see. Yeah, see, string's not even in this file. So I guess, we'll put this all the way at the bottom. And we'll say, we'll export this, and we'll say, we'll do a const character array, and we'll do Xform to string, k handle, t, right? And I'm actually just gonna copy this guy. So this returns a string representation of the Xform pointed to by the given handle, right? The Xform whose, or the Xform, I should say, the Xform, the handle to the Xform to retrieve as a string. And then the string in, or the Xform in string format, right? Let's see. Max, how's it going over there on the YouTube side? Hello, Chads. Nice to see you. Rico, good to see you too. What do you think about Notion as a project? Management, tracker, documentation tool. I have not used it, so I can't speak on it. I've actually tried a couple times throughout the series, trying different like project management tools. Like I tried Trello, I tried using GitHub projects, which I still kind of use that for bugs. But I don't know, like they kind of just kept getting in the way for me. So literally, I just keep it low tech. Like I just keep a to-do list, right? And this is all the work items I need are in here, right? We've got plenty to do in here. This is kind of how I work. And then bugs, I just work out of the GitHub queue. So for right now, that's working. Maybe in the future, if there are like a team of people working on this, then something like this obviously might not be enough. But for right now, where it's just me, low tech is best, I think. I switched to Vim instead of VS Code. Yeah, this is NeoVim. Yep. I made that switch quite a while ago, actually. And actually, I prefer programming on Linux too, but I've got an issue on. I recently redid my Linux install completely from scratch, and now I've got an issue where like the newest version of GDB, when it hooks into the application, it takes forever to actually start up, and it's the debugger, because if I run it without a debugger, it's quick. So the debugger over there is it takes like a good 10-15 seconds to just launch, and that's not acceptable, right? So I'm trying to look for a workaround for that, so that I can switch back to Linux, actually. Obsidian has a better project management tool than anything I've used so far. I've heard things about Obsidian. Also, I've not used that too. Just simple markdown to keep a to-do list. Exactly. It's low tech. It's easy to maintain. It's easily searched, easily modified, right? Sometimes low tech is best. You can't really go wrong with it, right? You don't have to have a database to store it up. You know, you don't have to worry about like logins and all that crap, or like ticket status or any of that crap, right? Like my status is it done or is it not done? And then I have a change log for like release notes. So like I don't really need it at this point anyway. All right, so let's implement this really quickly. So let's go to Xform system. Let's see, this is all of our static methods. Okay, here we go. So right here. Right. So the first thing we need to do, obviously, is actually I can actually literally just do this. Right, I can do this, and then what I'm going to do is, if this fails for some reason, I'm going to return 0. All right, and this is actually going to be an error. Should I error it? Like before we actually call toString on it, we should verify that it's like valid, right? Invalid handle passed to Xform toString. Returning null. I would consider that an error because like the fallout from that could break things, right? The other reason that I would do that is because if we wrote a blank string to a file, right? If we actually wrote out this, like we just do that, like how do you then parse that? Like then you have to look for I suppose you could look for an empty string and just do an identity. I don't know. It feels weird to me, right? I feel like it shouldn't even exist at all. It shouldn't be serialized at all, if that's the case. All right. So we basically need to grab a few different things. So we do vec3 position is states position. Oh, and equals might help there. States positions subindex, right? We'll do scale. So scales. And then rotation. And that needs to be a quaternion. Right? So we retrieve those things. And I'm just trying to think, maybe we should set up a buffer to put this into. I can't imagine like 512 characters should be more than enough for this, right? So let's do, you know what? Let's go crazy. Let's just say, yeah, you know what? 512 characters is good enough. So do a character array, buffer 512. Right? We'll do a string format. Destination is buffer. Oops, the buffer. Bugger too. So the format string is going to basically look like this, right? It's going to be 10 floats essentially. So we're going to have float. And then I think, let's see. Okay, so the first three are going to be position, then rotation, then scale. Right? Did I get? Yeah, 10. Okay. All right, so we'll do position.x, position.y, position.z, rotation.x, rotation.y, rotation.z, rotation.w, and then scale.x, scale.y, scale.z. All right, so we'll string format into that buffer, and then we'll do a return string duplicate buffer. And you know what, just to be safe, because this is likely to contain rubbish, let's just do a 0 memory on buffer. And size of character times 512. Right? Just be a little safe there. All right. And that's basically all there is to it, right? We just do a quick string format and then return that. And we should be good. All right. So if we have a valid handle, the string value that we're going to want is going to be xform to string, and the handle that we're going to have is the view node xform handle. And that's just going to string that for us, slam it in the strings value, and then we push that into the properties array. Does that make sense? Yes. Okay. All right, so that's xform. Is optional. So make sure there is a valid handle to one before serializing. All right. Cool. Tammin with a 10 stream streak. How's it going, bud? Good to see you. Bit late, but you're here. Hey, I appreciate you being here. Welcome. You're just racking up those points, aren't you? That's kind of awesome. All right, let's see. What do you think someone has to accomplish, whether professional or as a hobby, to wear the title of software engineer? And do you think someone needs a degree to call themselves a software engineer? So I'm going to go ahead and answer that second question first, and the answer to that is absolutely not, right? I am a self-taught programmer. I do have a degree, but it's in game art and design. It is not in programming, right? I taught myself how to program. I did not go to school for it. In fact, the programming classes that I took in school, because they were required, I could have taught. And so, I've been doing it for professionally now for almost 20 years. And as a hobbyist for 30 years. So, you don't need a degree for that, right? There are plenty of people out there that do it without a degree. So you absolutely do not need one. Will it help you? Maybe. I'm not going to say don't do it. I'm just going to say you don't necessarily need one, right? And the other thing to bear in mind is once you have experience under your belt, the degree matters less and less as you get that experience, right? So at a certain point, your degree really doesn't even matter, right? I don't even mention my degree when I apply for jobs. So what do you think someone has to accomplish, professional or a hobby, to wear the title of software engineer? You basically just have to know how to write code, right? You should have developed some things, made some things. But that's it, right? That's what software engineers do. They write code. And if you can write code and make things, then you're a software engineer, right? There are different levels of that, of course. There's entry level versus what you might call a senior or an architect or different things like that. And those all come with different levels of experience, right? But as a junior, you're or even an intern level, if that's a thing, right? All you have to do is have the ability to write code and have the ability to learn and have the drive to learn on your own, right? And not necessarily require somebody to sort of handhold you through the whole thing, right? That's ideal, anyway. I hope that answers the question. All right. Alden, first time chat, welcome. Hi, C game dev is a rarity these days. Why C? Preference. I like C because it is a much simpler language than C++. C++ gets increasingly complex and verbose with every single release, right? And I'm not a fan of it. All that verbosity, all that that complexity that comes with the C++ also comes at a cost of higher compilation time, right? C compiles much faster than C++. And I also don't use object-oriented programming. I don't really use the features that C++ has, right? Like I don't use operator overloading. I don't use function overloading. I certainly don't use templates. And so, that's more or less what it is, right? It's preference, but there are some technical reasons. You look 34, you've been doing this professionally 20 years, almost 20 years. Yeah. Yeah. I did some contract work, when I was in college, but yeah, that started, I started college in 2004 and I was doing contract work right around that time too. So yeah, 20 years. I look 34. I'm 38 actually. So I appreciate that. But yeah, I actually started programming when I was 7, with a MS-DOS computer using QBasic back in the day. So I've been doing it a while. Taught myself everything that I know. And or, learned it from studying other people's code, stuff like that. But yeah, so you're not far off. You said 34. I appreciate that. You gave me some years back, right? You also love C more than C++. If you like C, you will love Odin. I've heard a lot about Odin, and it is something I'm actually going to try along with Zig. Should definitely check it out. It's just a better version of C, in my opinion. Definitely my favorite language now. Yeah, I've heard a lot of good things about Odin. I've heard a lot of good things about Zig. My problem with both of them is I think they're too new to be stable yet, which is why I didn't choose them for this project. Started in 93. Your birth year? Yeah. Yeah. I am constantly made to feel old on this stream, for sure. What was it? Somebody said that that they were 1 year old when DirectX 9 came out or something like that. And I was just like, oh, okay. Tim, and you were born in 95? Nice. Yeah. Makes a guy feel old sometimes. It's all good though. We get there eventually, right? And hey, I'd rather be old than not around. So it is what it is. Nice meeting another QBasic programmer. Awesome. Yeah, I haven't looked at QBasic. I haven't looked at QBasic now in well over 20 years. It's probably been 25 years since I've looked at QBasic for sure. Last time you wrote C was in the Mosaic browser. I remember Mosaic. QBasic Pog. You know, that it might actually be super fun to revisit QBasic at some point. It's been so long that since I've looked at it, I honestly don't even know that I could write anything in it anymore. I didn't write anything complex. Of course, I was like 7 when I was messing around with it, but like, you know, and I messed with it on and off for years, but I never wrote anything more complex than like menu-based games in it, right? So yeah, might be fun to write like a software renderer or something in that. You have zero knowledge of coding. Thor from Pirate Software got me interested in anything coding. Yeah, that's awesome. He's very good at motivating people. Thor's good people. I like him. The oldest tech you used was Fortran. I used COBOL. I had to do COBOL at a previous job. That was fun. Thank you for the follow. Appreciate that. I've thought about doing a few retro programming pilgrimages. Yeah, I know, right? That might be a fun thing that we could explore on the channel at some point. It's like maybe a QBasic thing, right? All right. So we've got this done. I suppose before we jump into attachments, we could just recurse the children real fast. So let's see. Here's the children property, right? So we have the properties. Those properties are all going to be the child nodes, right? So it's basically going to be the same as the code that called this initially. So I think I can actually just come down here and call ads, because there are ads playing. Good timing on that, I guess. So for those of you who are new to the stream and or over on the YouTube side, we break the stream once every 30 minutes for 90 seconds because that's how often we're fed ads on the Twitch side. There's nothing that we can do to really get around that, right? So we pause the stream so that nobody misses any content. And I usually say, hydrate during this. Right? I put a timer up on the screen, so if you guys need to see how long it's going to be till we get back, it's there for you. All right. So got a little over 20 seconds left, and then we'll jump back into it. And ads are done. Okay, so for a little bit of clarity, because I know that obviously while ads are running, you guys can't hear what I'm talking about. So one thing that we do on this stream, out of respect to the viewers, is whenever ads come up on the Twitch side, we do stream to both YouTube and Twitch at the same time. Whenever ads come up on the Twitch side, I go ahead and pause the stream. So every 30 minutes for 90 seconds, we're fed ads, or I should say it's up to 90 seconds. It varies based on region and locale. Some people get the full 90 seconds. Some people only get a portion of that. We pause the stream so that nobody misses any content, right? And so I pause the stream across the board so that it's an even playing field, so that nobody misses any content. We don't miss what we're talking about. I put a timer on the screen so that you guys are aware of how long the ad break is going to be and when to come back. So if you want, I usually suggest people hydrate during that because hydration is good for your health, right? And so, yeah, I think that just about covers it, right? Cool. You start explaining to new people me as the ad starts. Yeah, exactly. So I was hoping to mention that before the actual ad kicked off, but it was a little bit too quick. But yeah, that's basically what we do. I never get ads, Brave browser. Yeah. So it varies on platform, region, and locale, right? So yeah. I always pause the stream though. Whenever ads are running, I put that screen up and I don't code anything unless I'm doing something that's super mundane, just so that you guys don't actually miss anything. So I think that's really important. And nothing is worse than you're watching a programming stream and then ads come up, cover the screen, you can't understand what the heck is going on. So thank you for the stretch redeem, by the way. Appreciate that. Oh, I needed that actually. All right, so basically what we are going to do is we are going to use essentially the same logic here to recurse our child nodes, right? So we're going to go back up to here, and we're going to recurse the children, okay? So let's see. Did I skip down too far? Yeah, I did. All right. So what we need to do is we need to look at the actual node itself to see how many children it has, right? So I'm just gonna paste this here for a second. And instead of root count, I'm gonna say child count, right? And instead of root indices, we're going to go with node. Was it node? View node, I think it was. Children, which is also a list of U32s, right? So it's a list of indices, right? So we can literally go through this right here and say, this is, instead of view root indices, we want view node children, right? So we get the index, which is at sub I. Then we grab the view node from that out of the view nodes array. We go ahead and we stand up a project or an object for that. We serialize that node, which basically just recursively calls this function. And then we need to push that into an array, right? So in this case, we are pushing to the children property, which is this guy here, which is an array, right? So it's essentially, we're pushing into this array right here, right? So for each one of those, we are creating a property, an object property, right? Which then gets deserialized recursively, right? So here is where we do that. We push into the children properties, that new node. We should probably rename this. So we'll say child node, just so that's not confusing, right? And so we serialize children. So we can actually knock that to do out, right? I hit the wrong button there, right? Okay, So that automatically takes care of the children for us. And then once we've recursed all the children, push those into the properties array for that. We then push the property, the children property itself into the properties of the node itself, right? And at that point, we can boot out of the function and work our way back up the tree until we're done. So the only thing that we have left to do, serialization-wise, is the attachments, which shouldn't be too difficult, actually. So I'm gonna tackle the more difficult attachments first. That way, the easy ones can just kind of fall into line afterwards. So let's see, what are we going to need? We're going to need to iterate the attachments, which is going to be something very similar to what we're doing for the children, right? So let's do a U32 attachment count equals the array length, and we want view node. Oh, that's right. We can't actually access attachments this way. So actually looping through these attachments might get a little bit tricky. So the attachments, the scene hierarchy knows nothing about attachments, right? It only knows about nodes. Separation of concerns and all that. So I guess we need to do... Think about this for a second. So we need to get attachments for the current node. And I guess that means we're going to have to check each individual attachment type to see if any attachments exist that are assigned to that. So let's see. Indexes into the attachment array for xform and resource lookups. So when we do mesh attachment indices, so we find a resource index or we push one. So if we do mesh attachments, we can look for mesh attachments that have a hierarchy node handle that matches what we're looking for. And then we can use the resource handle to extract what we need to. That is not the cleanest way to look that up. But I suppose since it only happens on a save operation, it's not that big a deal. So all right, so let me think about this. So we need to look through each attachment type and see if the hierarchy node handle matches the node handle of the current node being serialized. If it does, use the resource handle to, index into the resource and or metadata arrays to obtain needed data. Okay. So I guess what we're going to do is we're going to say mesh attachments. Oh, we have to do this by type, which kind of sucks. what we really need is another view that gives us a relational view to this stuff. So I'm going to say also to do a relational view that allows for easy lookups of attachments for a particular node. So we'll do mesh count is equal to that. Are you visualizing what you want to do and what will happen when you do next? Because coding kind of like chess. Sometimes, yes. Particularly when I'm doing the 3D stuff, then yeah, I visualize a lot of it in my head, for sure. Sometimes with this stuff, I just have to kind of think about how all the data points sort of interact with one another and how to connect those things. Working with hierarchies always provides good contents with all the children stuff. Like, what are we going to do with the children? Yeah, exactly. Yeah, hierarchies get crazy sometimes, especially when we separate them out like we have, where you can have transforms or not. Oh, thank you again for the stretch redeem there. Appreciate that. Let's see. People tell Thor he's old too. Yeah. And Thor is 36, right? So he's younger than me. So yeah. You learned HTML using Netscape Composer. Nice. That is old school. Okay. I don't like that we have to do it this way. So I think a view is going to be the right way to go, but I don't really want to detract from what we're doing because this is the last step of serialization, right? So I don't really want to step away from that. Let's do U32 m equals 0. M is less than mesh count plus m. And we'll do if, let's see, S mesh attachments sub m, hierarchy node handle, handle index equals view node, node handle, handle index. Then we have a match. All right. So found one. And so then we can deserialize. So in this case, we need to grab a couple things for a mesh. Let's see. So we need to add a type property of static mesh, and then we need to add a resource name, which we pull from the metadata. So technically we could do this in line, right? We could just serialize it right here and there. Should I suppose I can always split it to a function later. I'm just going to do it in line for now. So let's do... Did we actually create an attachment yet? No, I don't think we have. Right, so we're going to have to create the attachment object first. So we'll do a case on object attachment. Attachment. Oh, wait a minute. We can't even create the object yet, actually. We need to create a property because we're pushing this into a detachments array, right? So case in property. This is actually going to be the attachment. Yes. Right? So attachment type is going to be JSON property type object, attachment, Ignacio, thank you for the follow over on the YouTube side. Appreciate that. So the attachment name, in this case, because it is pushed into an array, we don't have a name. And then attachment value dot o dot type is going to be JSON object type object, and then attachment value o dot properties, right, which is going to be these two things here, is going to be equal to darray create, and that's going to be JSON property type there. Right, and then so create the object array entry, right, and then add properties to it. So we're gonna do we'll do name first, or actually we'll do type. There is no name for this one. So we'll say JSON property attachment name dot type, and this is going to be JSON property type string attachment name name, funny enough, equals type. So string duplicates type, and then attachment name value s is equal to string duplicates, and we're going to use static mesh, right? So this is just a known property that gets added every single time. So then we can do darray push, and to the attachment value o properties array, we will push attachment name. Okay, so that's the type, and then the only other thing is going to be the resource name, which is going to be a lot like this. So I'm actually going to copy this and come down here and change this to resource name, right? And this is going to be attachment resource name resource name right, and we're going to push that as well, right? So the resource name name is going to be resource name, and the value is going to be string duplicates, and we're going to want s mesh metadata sub m resource name. Right, so we just take a copy of that string and then push that to our properties, and that's the serialization rather of the static mesh type. So once we have that, then we need to do a final darray push, and that's going to be into the attachments property value object properties, and we're going to push attachment into the attachments array. All right. And so basically the serialization is going to work exactly like this for all the other types. It's mostly going to be a copy pasta, right? So terrain is going to be almost exactly like this, and skybox is going to be almost exactly like this. I think I'll be more likely to drop by in YouTube versus Twitch. That's fair. Fair enough. I do try to keep an eye on both, so. And if I don't, call me on it, right? Okay. So that's for meshes. We're going to wind up with some duplicate code here again, I think. Because we're going to have to do this for each type, right? And each type has got like lots of properties that it has to go through. I am eventually going to split these out into separate functions, but for right now, I'm not going to worry about it. So I think what I'm going to do is right, we'll do meshes there. And then we're going to do, let's do skyboxes. If I can type it correctly. So we'll say skybox counts, skybox attachments, right? Skybox count, and then we'll do skybox attachments. All right, and I think we need this in one. Actually, I think that's it. Okay, so we look at the skybox attachments. Again, we match on handle index. The attachment is here. So that is going to wind up being exactly the same. Nothing crazy there. The type here is going to be skybox. And then the resource name is actually going to be, I think we call it cube map name. Yeah, cube map name. Cube map name. So that's just going to be cube map name. And then instead of mesh metadata, it's going to be skybox metadata. Cube map name, right? And I guess let's just rename this. Cube map name. Right, so we push that, and then we have that attachment, and that's done, right? So we're probably going to want to generalize this, right? And like handle some of these things in like a function. We're definitely going to want to split this stuff out into functions. I'm only not doing that initially because I want to test all of these different units individually. And then handle it from there, right? So terrains. So we've got terrain count. Terrain attachments. Terrain counts. Terrain attachments. So again, we do the same thing. In this case, the type is going to be changed to terrain. And then actually we have, I believe we have two properties for terrain. Yeah, we have the name and the resource name, right? So let's actually go with resource name. We'll do that first. Right? So resource name. Resource name. This is going to be terrain metadata. Resource name. All right, so we'll do resource name, and then we'll actually take a copy of this. right? And this is just going to be straight up name, right? So we're just going to do attachment. Oh, I can't use attachment name. Shoot. Attachment. Name property, I guess. Attachment name property. Okay. And this is just going to be resource. From resource name, it's just going to be name. And then this is also going to be just name. And then we push that. This is going to be, yep, okay. So there's name, resource name, and then we push that. All right, so those are all the ones that deal with metadata. From here on out, we have the only other things that we have to do are the light types, which are, they already contain the data that we need, right? So we can actually just pull those directly from those attachments themselves. So I think what I'm going to do is, I guess I will do, let's do this first one. Come down here. And we're going to do directional lights first. Directional light attachments. All right, so directional light attachments. Okay. So the type is going to be directional light. Just let me go up here because we're actually going to need a number of properties, right? So we don't need type. We're going to need color, and that's going to be stored as a string, right? So instead of that, we are going to do S directional lights sub M data color, and then we're going to do vec for toString, or is it string? Oh shoot, we don't have that, do we? Do we really not have that? I thought we did have the capability to change that to strings. String to vec4. Oh, we have ads. Excuse me. So we've got about 30 seconds on ads. Then we will be right back. D. Denny, thank you for the follow. Appreciate that. Welcome. All right. We are back ads are dead. So, it doesn't look like we have a bunch of string 2 types, but we don't have types 2 string. The only other thing, maybe it's in KMath. I don't think so, though. Nope. And this is probably actually where it should exist, right? Well, no, probably not, because we have the other version of it in the strings file. So I guess, shoot. Okay. I'm just going to create the one that we need for right now. And then I'll create the others later. So let's go with const character array vec4 to string, right? And then we'll do vec4 v. And I'm just going to copy this one, and I'll just change the text on there. Creates a string representation of the provided vector. Note, string is allocated, so the caller should free it. Okay, so we don't need that. And then this could be just v. The vector to convert to string. The string representation of the vector. Right? So we've got that. So we have string 2 vec4, and now we have vec4 to string. And all this is going to do is we're going to, again, just do a character array, right? And we're just going to use, we don't really need anything too crazy. I'll just use 100 characters, right? That should be more than enough. I don't even think we're going to use 50. But let's just go big, right? Buffer, and then K0 memory, buffer, size of character times 100. Then we'll do a string format. The destination is going to be buffer, the format string, Nguyen from YouTube, thank you for the follow. Appreciate that. Okay, so in this case, we want to write out 4 floating point numbers separated by spaces, right? So what we're going to do here is we're going to say v.x, v.y, v.z, and v.w. Right? And then we're going to return string duplicate buffer. Brackets. Oh, I put the brackets in the wrong place. What a noob. There we go. Okay, so now we have vec4 to string. let's see. So we can do vec for to string. Pass through the color, right? So we have that here as attachment name. I'm going to rename this to attachment color, right? And actually, direction is going to be the same thing because it's also a vector for, right? So that's going to be pretty easy to duplicate. So let's do direction, right? Right. And so for that, instead of the color, we're just going to use direction, right? So that's another one. Whoops, label this direction. Okay. Okay. So we have that. We're going to take this one up here. This is the one we're going to actually treat as the name. So the name is just going to be here. And then what we want is, oh, it's not going to be name, it's going to be type. Sorry. Type. So the type is going to be the attachment type. Attachment type. Attachment type. Okay. So it's going to be type. And then string duplicate is going to be directional light. Okay. All right. So we have that. We have the type, color, direction. So the other things that we have to parse out of this guy are the shadow distance, the shadow fade distance, and the shadow split. And those are all floats. They don't look like it here, but they are actually floats. So let's do shadow distance. All right, and I'm actually just going to copy this because it's going to be very similar. So attachment shadow distance. Shadow distance. Shadow distance, right? And then we're going to do F32 to, oh, do we really not have that either? I suppose I could do it in line, but we don't have, nope. We don't have F32 to string either. That's really annoying. Okay, so this is going to be, instead of direction, shadow distance. Let's go write this one. So let's see. We'll write it right below this one. F32 to string. Then we have F32, F. Creates a string representation of the provided float. Right, and then this is going to be the floats to convert to string, and then the float representation of the, whoops, the string representation of the provided float. All right, so let's go to this guy, and we'll put this right here. So in this case, we'll do a character array. I think 20 should be more than enough, right? And then we'll do a K0 memory buffer size of character times 20. And then string formats buffer just a single float. And we're going to pass in F, right? And then return string duplicates buffer. Georgie42, thank you for the follow. Appreciate that. Welcome. All right. So that will give us what we need there. Now we have shadow distance. Then we have shadow fade distance. Right, so oops. Attachment, oops, Q. Attachment shadow fade distance. Attachment shadow fade distance. There we go. Okay. So here we want shadow fade distance. Shadow fade distance. Okay. And then one more. Hi, what distro is this? So I'm actually currently running on Windows, but I am switching to Pop! OS in a bit. But yeah, I'm currently running on Windows. I dual boot, so I can switch back and forth. I was running Arch for a while. I'm distro hopping to try some different setups, right? So attachment shadow split multiplier. Shadow split multiplier. Right, so we're going to push this one as well. Shadow split mult. And shadow split mult. Okay. So that's all the properties parsed for this guy. Which is pretty sweet, right? So that should go ahead and push onto that, and that should be successful. The other thing that I'm going to do, and I know I'm running a little bit over here, so I'm actually going to be wrapping up here very shortly for tonight. But I only have one type left, and I don't really want to leave that one dangling, right? And that's just literally this one. So we do have a position, which is a vector 4 in this case, and we do have a color. So we already have everything we need here with just a slight refactoring, right? Blackbird, thank you for the follow over on the YouTube side. Appreciate that. Welcome. So I'm going to grab... I'm going to grab this. Right, and like I said, eventually, once we actually get all of this stuff up and running, I am going to extract all of these out to functions and get rid of some of the repeated parts like this stuff. extract it into functions as well to sort of narrow the scope of this down a little bit. But for right now, we're just interested in getting it to work. So we have point light counts, point light attachments, point light counts, point light attachments. Okay. So the outer object doesn't need to change at all. The type just needs to be changed to point light. The color can actually stay as is, which is pretty cool. Direction is going to change to position. So let's rename this one to position, and change this to look at position. I just realized that this also needs to be point lights sub m position, right? This needs to be point lights, point lights, point lights. Okay. So now we have type, color, and position done, right? So we need these, we need the constant f, linear, and quadratic, right? So constant f. So this is going to be renamed to attachment constant f. Right, constant f, constant f. All right, this one is going to be linear. So we're going to rename this guy to attachment linear. This is just going to be linear, linear. Okay, and then finally this last one is going to be quadratic. And we're going to rename this, or redo this, quadratic. Quadratic. And what do you know? It's the same number of properties too, so it'll just kind of slide right in. All right. And that should do it for the serialization of our attachments, right? So we can actually remove this. We still could use a relational view that allows us to look up the attachments a little bit easier than this, but I suppose that's not terrible, right? The fact that we have to loop through these kind of sucks, but it's not the end of the world, I suppose. Again, this only happens during save operations, so I'm not really that worried about it. Okay. Even though I know this is not going to run, I'm going to go ahead and build it. Let's see, directional light counts unused. Okay, I'm glad I actually did that because I wouldn't have caught that. So let's see. Aha, yeah. Directional light counts. They do the same thing for point lights, I wonder. Point light count, point light count. Okay. Okay. I think we're good. Use Arch, you're working on Arch ISO. Nice. Okay. Yeah, I used Arch for a couple years, right? But I got tired of the bleeding edge stuff breaking my dev environment all the time. which is really great when it happens right before stream too. All right. So what I'm going to do is, there's no point to even running this yet, because we know for a fact that this is not going to actually get us where we need. We still have a couple steps left, which we're going to handle on the next stream. So to recap, what scene save does right now is it builds a case and tree, right? Creates one of those. We add the global properties here. We add this nodes array. And then we go into serializing each node. Each node can serialize its properties, its attachments, as well as its children if it has them, Xform, things like that. Once that's done, which that part should be done now, we'll have to exercise that to be sure later on. We can then pass that to the parser, to the case and parser rather, to output a string. And then that string can then be written to a file, which should make it come out to look something like this, right? So we're going to pick that up on the next stream. And we'll probably, unless we run into like some major issues, we'll probably wind up knocking that out kind of quick. It's just kind of late tonight, and I do have to work in the morning, so I'm going to go ahead and shut this down now. But let me just catch up and see if there's any messages here. Maybe I'm just not deving hard enough, but Arch doesn't really break for me. So Arch itself wasn't breaking for me. What kept breaking is the freaking NVIDIA drivers. Right? And because there was constant updates for that, it was breaking for me. Yeah, there was just the one time with NVIDIA drivers, but then again, it's NVIDIA on Linux. Yes, exactly. Which is why I stepped away from it, because it was infuriating. And the worst part about it was, at the time, I was also streaming off of that machine. So whenever my NVIDIA driver would die, the stream would go down with it because it would take OBS with it. So because of that, I actually stream off of my laptop now. That's what actually runs OBS, and I just patch my desktop over to it. Using NVIDIA DKMS worked for me, never broke again. That actually, I had to switch back and forth a few times between that and just the regular one, because one would break and then the other one would work for a bit, and then I think part of the problem is also I had like 5 desktop environments installed, because I'm always distro hopping and trying new stuff. So yeah. Torvald's opinion on NVIDIA. Yes, I agree. Yep. But yeah. Anyway, so that is going to do it for tonight. I know some of you guys just kind of came into the stream, but you know, it's late. I have to work in the morning. Code 871 over on the YouTube side. Hello. But if you haven't already, I would encourage you to follow me on one side, if not both, the YouTube or Twitch. I really appreciate those follows. Helps me grow the channel and hopefully reach more people, right? So I do appreciate that. With that said, let me see who we are going to raid tonight. Okay, actually, I see who we're going to raid right away. So we are going to raid CM Griffing. Chris is a pretty awesome dude. He's another dev here on Twitch. I don't know what he's working on at the moment. Looks like he's learning something brand new from scratch on stream, which is pretty cool. So he's a good friend of mine, and yeah, I'm going to raid him. So if you don't know who he is, definitely give him a follow. He's a cool dude. And I'm probably going to have to do a raid and dash because, like I said, it's kind of late. But that is basically it for tonight. So thank you guys so much for joining me. I appreciate it. And I will see you guys in the next stream. See ya.